What if I told you the solution to Earth's energy crisis is just sitting there, right on the surface of the moon? We're talking about a fuel so powerful it could literally change everything for us. But, as we reach for the stars to fix our problems down here, a huge question comes up. Are we just about to create a whole new mess up there? So let's dig into the science, the engineering, and some of the really big questions this whole idea brings up.
Okay, get ready for this number. 19 million gigawatt years. I mean, what does that even mean? Well, that's the insane amount of energy that just 1 million tons of this special stuff from the moon, it's called helium-3, could potentially generate. To put that in perspective for you, we're talking about powering our entire planet for centuries with just a tiny piece of the moon. The potential here, it's just mind-boggling.
So, what is this miracle fuel anyway? Well, it's called helium-3. It's this light, totally stable version of helium that's super, super rare here on Earth. Why? Because for billions of years, the solar wind has just been blasting the moon's surface with it, and it's built up in the lunar soil. And here's the kicker, what makes it so special. When you fuse it, it lets loose a ton of energy, and it does it in a way that's way cleaner and safer than any nuclear reaction we have today.
Okay, so why are people calling this stuff the holy grail of clean energy? Let's get into the science behind all the excitement.
You see, the real genius of helium-3 is how it gives off energy. Your typical nuclear reaction, it shoots out these dangerous, high-energy neutrons. Not great. But helium-3 fusion, that creates charged particles instead. Now, why does that matter? Because it means we can turn that energy directly into electricity, super efficiently. And we get way, way less radioactive waste out of the deal. It's not just an improvement, it's a total game changer for nuclear tech. Safer, cleaner, and a whole lot more powerful.
So how'd we even get our hands on it? Well, check this out. This chart comes from a real Apollo lunar sample, and it shows you exactly how it works. See, the moon's surface dust, they call it regolith, has been soaking up these gases for eons. And when you heat that dust up, poof, the trapped gases come right out. You can even see the spike for helium right there on the chart. The science is actually pretty simple at its core. Just heat up the lunar soil, and you can collect all these gases that have been stuck there for billions of years, including that precious helium-3.
Right, but simple in theory is a long way from easy to do. So how would we actually pull off a mining operation on the moon? Let's take a look at some of the engineering ideas.
So, one of the main ideas is a kind of mobile lunar miner. Just picture it, a whole fleet of these rovers crawling across the moon's surface, scooping up that superfine dust and feeding it into a machine. They'd use focused sunlight to bake the dust at insane temperatures, all while dealing with the moon's crazy vacuum and wild temperature swings. The whole point is to release that trapped helium-3 and other useful gases, which they then collect and store to bring back home to Earth.
But we really have to talk about the scale here, because it's just staggering. To get just 33 kilograms of helium-3, now that's enough to power a big city for a whole year, you'd have to mine and process almost 5 million tons of moon dust. This is not some small-time project. We are talking about massive industrial-scale mining on another world.
So to deal with that kind of scale, engineers are dreaming up different ideas, like this one called the spiral miner. The idea is, instead of having one giant machine do everything, you have a smaller, mobile miner that's hooked up to a central processing plant. By splitting up the jobs, mining here, processing there, the whole operation could be way more flexible and efficient. You could have a bunch of these smaller, nimble miners zipping around, while the central hub does all the heavy lifting of actually getting the gas out. And then there's an even more futuristic idea. It's called in situ extraction, which basically just means in place. Instead of digging up and hauling millions of tons of soil, what if you could just place a huge dome on the surface? Then you'd use heaters to warm up the ground right underneath it and just collect the gases as they seep out. It's a really interesting and maybe less destructive way to tackle this enormous job.
Unlimited clean energy from the moon. I mean, it sounds perfect, right? The ultimate answer to one of our biggest problems. But this is where the story takes a hard turn. Because we have to ask the really tough question. In our rush to solve this one crisis, are we about to stumble blindly into creating an even bigger one?
And this image, it just nails the core problem we're facing. Think of it like a seesaw. On one side, you've got sustainability from space. That's all the ways we use space to help Earth. On the other side, you have sustainability of space, which is about protecting space itself from us. And right now, that seesaw is dangerously out of whack.
This whole situation leads us to something called the space sustainability paradox. It's a classic case of unintended consequences, really. The more we use space to try and make Earth more sustainable, with things like climate satellites or even lunar energy, the more we risk making space itself totally unsustainable. Let's break that down a little more. Sustainability from space, that's all the good stuff we get. It's GPS, global communications, and maybe one day, clean energy from the moon. But sustainability of space, that's the bill that comes due. It's the growing cloud of space junk, the pollution from all those rocket launches, the whole environmental footprint of our space activities. And that's the paradox in a nutshell. Chasing the first one is creating a massive problem for the second.
For decades, pretty much everyone has treated space like a global commons. This infinite shared resource that belongs to nobody and everybody at the same time. This is a textbook tragedy of the commons situation, exactly like overfishing in the oceans. When you have a shared, unregulated resource, everyone is incentivized to just take what they can, and that can lead to the whole system collapsing.
And this graph, it shows so clearly that space isn't infinite. Just like any other environment, our orbits have a carrying capacity, a limit to how much they can handle. If we just keep on with business as usual, we're going to hit a tipping point where collisions and debris make some of our most important orbits totally unusable. And look, the number of working satellites could actually start to go down. We are literally racing towards a limit that we created ourselves.
So let's zoom in on the specific things that are pushing us toward that tipping point. These are the hidden costs of our big ambitions in space.
Yeah, and it's so much more than just space junk, Every single mission has a full life cycle impact. You've got the pollution from building the rockets right here on Earth. You've got the contamination in our atmosphere from launches and from thousands of old satellites burning up when they fall back down. And all of that? That's before we even start to think about the insane scale of something like mining the moon. That would mean thousands of launches, a permanent base up there, a whole new infrastructure, all of it with its own huge environmental footprint.
So what do we do? How do we even begin to tackle this? We can't just stop going to space, but we definitely can't keep going like this. What we need is a whole new way of thinking, a new framework that lets us get all the amazing benefits from space without trashing the very environment that makes it all possible.
One really powerful idea that's out there is something called the donut economics model. Just picture a donut. The inner ring is our social foundation. That's all the stuff people need to live a good life, like food, water, and energy. The outer ring is our planet's ecological ceiling. Those are the hard environmental limits we can't cross. The sweet spot, the goal, is to live inside the donut, making sure everyone has what they need without wrecking the planet.
And now, for the space age, experts are saying we need a crucial update to this model. They want to add a 10th planetary boundary, orbital space depletion. This would make it official. It would recognize that the space around our planet isn't just an empty void. It's a finite natural resource, another part of our planetary ecosystem that we absolutely have to protect.
So how do we stay inside that new boundary? Well, some researchers have come up with a really powerful framework called the 3 zeros. It's pretty straightforward. Number 1, zero debris. We just have to stop treating our orbits like a garbage dump. Number 2, zero negative impacts on Earth. That means looking at the whole picture, from building the rockets to launching them and bringing them home. And number 3, zero unsustainable resources. We have to start thinking about a circular economy in space, where we reuse and recycle everything we can.
And this brings us full circle, right back to where we started. This quote really just says it all. Look, mining the moon for clean energy, it has great intentions, right? A sustainable motive. But that's not enough. We have to look at the whole system. The thousands of launches, the pollution, the traffic jam in orbit, to figure out if the solution is actually sustainable, or if we're just swapping one huge problem for another.
So that's the dilemma we're left with. The promise of the moon it's huge, a potential answer to one of our biggest challenges. But the real question isn't can we do this anymore, it's should we? And if we go for it, are we really prepared to be more than just explorers? Are we ready to be responsible stewards of this incredible new frontier? That's the challenge, and honestly, that's the choice that our generation has to make.